Hi everyone, welcome to Math 150 College Algebra. Today we will learn about linear inequalities and absolute value inequalities. Solving an inequality. Solving an inequality is the process of finding the set of numbers that make the inequality a true statement. These numbers are called the solution of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. Interval notation. The open interval a, b represents the set of real numbers between but not including a and b. The open interval AB equal the set of all real number x such that a less than x less than b. The closed interval, we use bracket, okay? The closed interval AB represents the set of real numbers between and including A and B. Okay, because close include. Is open is not include. Okay, so the closed interval A, B equal the set of all real number x such that A less than or equal to x less than or equal to B. The infinite interval A to infinity represents the set of real numbers that are greater than A. So the infinite interval A to infinity equal the set of all real number x such that x greater than A. The infinity interval negative infinity to B, okay, close, it means bracket is closed, represent the set of real numbers that are less than or equal to B. Okay, so we can write down it like this. Okay. So now go to the next one. Parentheses and bracket in interval notation. Parentheses indicate endpoints that are not included in an interval. Square brackets indicate endpoints that are included in an interval. Parentheses are always used with infinity or negative infinity. So if we have infinity, we always use parentheses, never bracket. Okay? Now, example. Express the interval in set builder notation and graph. Close interval, yeah, 1 to 3.5. Okay, from 1 to 3.5. So we can write down, yeah, the set of all real number x such that 1 less than or equal x, x less than or equal to 3.5. Okay, just look at 1. Yeah, this is bracket, just this is 1 and use bracket. 3.5, just put 3.5 and bracket because this is close. Okay, the next one. Express the interval in set builder notation and graph. Okay, remember this is parenthesis. Always, yeah, negative infinity, always parenthesis. So go over there. This is negative infinity. Okay, now negative 1. This one negative 1. But it's open. This parenthesis. Okay. Find the intersection and unions of two intervals. 1. Graph each interval on a number line. 2. A. To find the intersection, take the portion of the number line that the two graphs have in common. B. To find the union, take the portion of the number lines representing the total collection of numbers in the two graphs. Example. Use graph to find the sets close interval 1 to 3, intersection open interval 2 to 6. Okay, first we just graph close interval 1 to 3. Yeah, so this is the first one, 1 to 3. Okay, so this is close. Yeah, 1 and 3 close. So it's better is the same. Yeah, this is I just put for the second graph. Yeah, make the same. Okay, 2 to 6. This is 2, 3, 4, 5, and 6. It's easy, yeah? This is 2, 3, 4, 5, and 6. Graph open interval 2 to 6. Yeah, from 2, this is open, yeah? To 6 open. Okay, so now, remember intersection. So if you can see, yeah, so this is, I just put line like this and like over here, this. Okay, this is the 3 is close. So you can put close over here. I just use black. You can see. Okay. So the answer for intersection. Okay. So number in both close interval 1, 3 and open interval 2, 6. The answer is 2 open, yeah, and 3 is close. Okay. Now, solving linear inequalities in one variable. A linear inequality in X can be written in one of the following form: AX plus B less than 0. Remember, A not equal 0, yeah? AX plus B greater than 0. AX plus B less than equal or equal to 0. AX plus B greater than or equal to 0. In general, when we multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol is reversed. Okay, so be careful. Yeah, if you time by negative or divide, yeah, multiply or divide the same, yeah. So change, yeah, change direction. So if you get the, if for example it's less than or equal, yeah, become if you time by negative or divide by negative, change. Okay, or like this, change become greater, become less than. Be careful, okay? Negative. This one you have to remember this one. Okay, multiply or divide both sides of inequality by a negative number. Okay, change. Okay, let's go to the example. Solve and graph the solution set on a number line. Okay, 2 minus 3x less than or equal to 5. Okay, so now okay, move, yeah, this one to the right side, become minus, yeah. So then it become negative 3x less than or equal 5 minus 2. Okay, so the answer become negative 3x less than or equal to 3, because 5 minus 2 is 3, yeah? So we need x. So because we need x, we divide by negative 3. Remember, okay? We have to reverse, yeah? The sign, the direction, okay? So this is less than, yeah, less than or equal to, change become greater than or equal to, because we divide by negative 3. change. Okay, so the answer becomes negative 3x divided by negative 3 greater than equal x 3 divided by negative 3. Cancel, become 1, yeah? So x greater than or equal negative 2. So remember, the arrow go to the right side. We just put negative 1 first over here. Okay, so the arrow go to the right side. So just move, go to over there. Okay, to the infinity. Okay, because this is equal, become bracket. Everybody follow this one? Okay, the solution over there is negative. From this one, we can copy. This is negative 1 to infinity. Open. Okay, now go to the next one. Solve the inequality 3 times the quantity x plus 1 greater than 3x plus 2. Use distributive property, yeah? 3 times x becomes 3x plus 3 times 1 is 3 greater than 3x plus 2. Okay, so distributive can cancel each other, yeah? Become 0. So 3 greater than 2, yes, it's right because 3 greater than 2 is right, yeah? The inequality is true for all value of x. The solution set is the set of all real numbers. You can put any number. You can put any x. Yeah, because negative 2 or negative 5 or negative 100, negative 1000 or 1000, 0, any number. Okay, so any number. So in interval notation, the solution is open, yeah, because from negative infinity to infinity. Because always open for infinity. Remember that, yeah? So now, in the set builder notation, the solution set is the set of all real number x such that x is a real number. Now, next one. Solve and graph the solution set on a number line. Okay? 1 less than or equal 2x plus 3 less than 11. So our goal is to isolate x in the middle. So I need x by itself like this. Okay. Now, 1 less than or equal to 2x plus 3 less than 11. So I did minus 3 in the middle. So I need minus 3 on the left side. I need minus 3 on the right side. Okay. So now everything minus by 3. Okay, I can write down over here, yeah? So 1 minus 3 less than or equal to 2x plus 3 minus 3 less than 11 minus 3. I can write down like this one, yeah? So 1 minus 3 is negative 2 less than or equal to 2x. This is 0, yeah? So less than 11 minus 3 is 8. Remember, I need x in the middle, yeah? So this one, I need x, yeah? So I have to divide by 2. The whole thing you have to divide by 2. Okay? So negative 2 divided by 2 is negative 1, yeah? 2 divided by 2 is become 1. Our goal, 8 divided by 2 is 4. So the interval notation, yeah? The solution is, because this is closed, so I just put bracket. This is open, just parenthesis. After that, just put the number negative 1, 2, 4. Okay, so we can write down in the set Buddha notation. Okay, just like this. Okay, for this one, the number line graph looks like, just write down. Yeah, make line. Okay, I forgot the ink. Okay, this is negative 1, this is 4. This is close, yeah? Just put bracket. 4 door is open, just parenthesis. Okay. Okay. Now, solving an absolute value inequality. If U is an algebraic expression and C is a positive number, 1. The solution of absolute value U less than C are the numbers that satisfy, okay, negative C less than U less than C, okay, between, okay, it's less than between, okay. The solution of absolute value U greater than C are the numbers that satisfy U less than negative C or U greater than C. These rules are valid if less than is replaced by less than or equal to, and greater than is replaced by greater than or equal to. So this the same, yeah. If negative C less than or equal U is less than or equal C. This is the same. So now U less than or equal negative C or U greater than or equal C. Okay. Now solve and graph the solution set on a number line. 18 less than absolute value quantity 6 minus 3x. To make easy, put the easier, put variable x on the left side, the number on the right side. That's to make easy. Okay. We begin by expressing the inequality with the absolute value expression on the left side. Okay, so we got absolute value 6 minus 3x greater than 18. So now we rewrite the inequality without absolute value bars. So absolute value quantity 6 minus 3x greater than 18 means 6 minus 3x less than negative 18 or 6 minus 3x greater than 18. Look at the, yeah, number 2, yeah? We use number 2. Okay, the formula number 2, so you remember that one. Now, we're going to solve this one. We solve this inequality separately. Okay, so 6 minus 3x is less than negative 18. Okay, move 6 to the right side, become minus. So become negative 3x less than negative 18 minus 6. So negative 3x less than negative 18 minus 6 is negative 24. We need x, so you have to divide by negative 3, divide by negative 2. Remember, divide by negative is mean you have to change, yeah? So less than become greater. So negative 3x divided by negative 3 greater than negative 24 divided by negative 3. This will become 1. So x greater than negative divided by negative is positive. 24 divided by 3 is 8. So we got the answer x greater than 8. Okay. Now, next one. 6 minus 3x greater than 18. So the same, yeah, move to the right side, become negative 3x greater than 18 minus 6. So the answer, negative 3x greater than 12. We need x, so you have divided by negative 3. Remember, again, yeah, because divided by negative number, so you have to change. Greater become less than. Okay, so negative 3x divided by negative 3 less than 12 divided by negative 3. So if you have cancel, become 1. So x less than 12 divided by negative 3 is negative 4. So the solution set is, okay, or just for this one, you have to graph the line, yeah, line graph, yeah, the number line graph looks like, so x greater than 8. So you can just put like this, sorry, the ink, yeah, this is negative 4, this is 8. X greater than 8, the arrow go to the right side, yeah, So, okay, this arrow go to the right side, open. Yeah, open, go to the right side. Okay, now another one, x less than -4. So open, arrow go to the left. So just go to the left. Okay, so you get the number line graph. Okay, that's all. Okay, see you on the next video. Bye-bye.